Alright, so let's actually get into how to name a particular compound. I think this is something you've all gone over before, so I just want to give you a brief review of how to go about doing this. Now, there are different ways of naming these compounds, depending on if you have an ionic compound or a covalent compound. What I am going to do is go through it by type, so I'll go over the ionic compounds first, then I'll go over covalent after that. But one thing that you need to know is that on the test, either in this class and also on the AP exam itself, they're not going to be separated out, so you are going to have to know which one is which. So just before we get into that, let me show you how to be able to figure out one type from another. Basically, all you're going to do is look at that first half of your compound. If that first half is a metal, you have an ionic compound. If it's a non-metal, then you have a covalent compound. So just go by that. Once you figure out what you have for that first half, then you can go about naming, depending on what it is that you have. Alright, so as the title of this video suggests, we are going to be dealing with going from ionic formula to name. But the first thing you want to do with any type of compound is be able to figure out if it's ionic or covalent, like I said before. So what you need to do is just split it in half and then figure out what you have here for your first half. Is it a metal or is it a non-metal? Metals, again, are on the left of the zigzag line on the periodic table. Non-metals are on the right side of the zigzag on the periodic table. So in this case, if you look at Mg, or look up Mg, you'll notice that it's on the left side, so this is a metal. So you have an ionic compound. Once you figure that out, now you can go about and do the next step, which in this case is just to figure out the charge of the second half of your compound. And the reason why you would do this is because of the fact that, if you remember, like I was saying, in an earlier video, we know the charges of all the main group elements, from group 1, 2, and then from 13 to 18. We know those charges, but the transition metals we don't know. So that means that if this were ever a transition metal, you wouldn't be able to figure out the charge by just looking at that first half. You would have to look at the second half. So that's why we go about doing this. Alright, so going back to this, with the N, if you remember valence electrons, on the periodic table N has 5, and everything is trying to get to 8, so then that would mean that the N would gain 3. It would be the easiest thing for it to do. So if it gains 3, that means it has a -3 charge, like that. Now, one thing you need to do is figure out the overall charge of this half, because of the fact that you need to balance off your charges. So in this case, you have a -3 and 2, so that means the charge of that particular half is a -6. That would mean that this side also has to be, well, it would have to be a +6 to balance out both sides. And let me just get rid of this for now. So now you have the Mg3 that you need to deal with. So like I said, this half of the compound has to be 6. You already have a 3 though, so the charge of the Mg would be a +2, just to balance that out. From there, you just name it. Mg is one of your main group elements, so you can just name it by looking at the periodic table, which in this case would just be magnesium. And then for the N, the second half of a compound, or a cation, would always be the name that you see on the periodic table, but make sure you put an ID ending at the end of it. So in this case, you'd have nitride. So the name for this compound would be magnesium nitride. Alright, here's the next example. Again, first thing you want to do, split it in half. You figure out if it's a metal, non-metal, if it's ionic, covalent. In this case, it's ionic, because that's all we're dealing with right now. So then, again, go to the second half and figure out the charge for that. Well, in this case, you have parentheses, and you have an SO4 within those parentheses. These are your polyatomic ions, which I mentioned in the tutorial that you need to memorize. This is the only way that you're going to know what the charges are for these particular ions. So if you were to memorize this or look it up in the tutorial, you would notice that SO4 has a -2 charge. Now the question is, do you multiply the -2 by the 3, like you did in the previous example? Now the rule for this is if you have a polyatomic ion and there are parentheses around it, then yes, you can multiply those two subscripts together. If there aren't any parentheses, then you can't. And I'll go over this a little bit more as well. So that's only with polyatomic ions. They have to be in parentheses to be able to multiply by the charge and the subscript. So in this case, the charge, the polyatomic is in parentheses, so you can multiply the -2 and the 3, so that becomes a -6. So then this means that the other side has to be 6 to be able to balance that out. So you have a 6, you already have a 2 there though, so 6 divided by 2, you'd have a +3 for the CR. Now CR, if you look it up on the periodic table, is a transition metal. And as I mentioned in the tutorial, if it's a transition metal, you use whatever name's on the periodic table, which CR is chromium, but then you have to make sure you put a Roman numeral down for the charge that you have. So in this case you have a +3, so the Roman numeral would be 3. And then SO4, again you have to memorize that, but if you memorized it, it's sulfate. So in this case the name for this is chromium 3 sulfate. Next example, again, split in half. Figure out the charge of the second half, so the CrO4 in this case. CrO4, if you looked it up or if you already memorized it, you would know that it has a -2 charge. Now here's the dilemma I was talking about in the first slide, where CrO4 is a polyatomic ion. So do you go and multiply those two together? Do you multiply the subscript by the charge? Well, the rule that I gave you was that a polyatomic has to be in parentheses to be able to do that. If it's not in parentheses, then you can't. In this case, CrO4 is not in parentheses, so you cannot multiply. Those two together. It would just be a -2 in this case for that charge. So you'd have a -2 over here, and then that would mean that the PB is a +2. Now in the tutorial that I made up for you, I did mention that PB is one of those elements that even though it's not necessarily a transition metal, you still need to give it a Roman numeral. It's one of those exceptions. So PB is lead. It's one of the exceptions, so you have to give it 2 for a Roman numeral, and then CrO4 is chromate. So that's how you'd name something like that. Last example is CaO. Again, split it, ionic, covalent, figure that out. In this case it's ionic. Figure out the charge in the second half, so you have an O. Because it's just an element, you can look on the periodic table and figure out what the charge is. O, for the valence electrons, you know that it's 6. Again, it's trying to get 8. So basically what's going to happen is it's trying to gain 2 electrons. So it would have a -2 charge here. There aren't any subscripts or anything. Anytime you have an element in with a subscript though, you can go and multiply them. You saw that on the first slide, or the second slide actually. But in this case there aren't any subscripts, so you don't have to worry about that. So you have a -2 for the oxygen. That means you need a +2 for the Ca. Ca, if you look on the periodic table, it's one of the main group elements, so you can just name it. So it would be calcium. O is just an element on the periodic table, so you can just name it, but again, because it's a cation, just make sure you put an IDE ending at the end, so it becomes calcium oxide. So that's how you figure out going from formula to name. Again, if you have a transition metal, you need to make sure you put the Roman numerals down, and also if you have a polyatomic ion for the second half of that compound, the only time you can multiply the subscript by the charge is if you have parentheses around it.